This will be for the con assignment, classify numbers rational and irrational. All right, so just a quick definition. So basically rational, well, let me start with irrational. Irrational would be when you have a decimal that never ends and is not repeating. Okay. So in other words, if you had 1/3, 1 divided by 3, that would be 0.33333 repeating, right? But that would be rational, okay? Because in order for it to be irrational, it would have to be a decimal that's not repeating. All right. And just some examples of irrational numbers. If you have pi, that's irrational. Pi never ends. It's like 3.14159, and it just keeps going. It never ends and it doesn't repeat. And if you have a square root of something that's not a perfect square, it will never end. Like if you have the square root of 2, that's going to be 1.414, and it just keeps going. Okay, if you have the square root of 25, that's just 5. Okay, so that's a rational number. But the square root of anything else that's not a perfect square, like square root of 26, it's just going to keep repeating if you try to convert it into a decimal. So it's pretty easy. All right. So is this rational or irrational? Well, just regular fractions, they're always going to be rational. Okay, if there's no square root, no pi, it's just going to be rational. Okay, square root of 50. If you tried to do this on the calculator, you would get 7 point something, something, something. It would just keep going. All right, so that's irrational. Unless it's a perfect square, it's irrational. All right, 7.11. This is a limited decimal. It does not continue. It doesn't keep going, so that's rational. Pi over 2, we said pi is irrational. Even if you divide it by 2, it's still irrational. Negative 0.32 repeating. Okay, 0.323232. It's repeating, so that's rational. 0.3 times pi. Remember, pi is irrational. And 6.6 repeating. Okay, it's going to be 6.666666. It keeps going, but it's repeating. It's not all different numbers. It's repeating, so that's rational. Light work.